What's up, everybody? It's 6 a.m. I can't speak. What's up, everybody? Welcome back to Flux Harmonic. I'm David Wilson, and today we're back with day 2 of the Ludum Dare 51 competition, where you try to make a game in 48 hours. Well, if you're doing the compo version of the event, at least, like I am. And the idea is that you, as a solo developer, go and try to write a game based on a specific theme that's been picked by the Ludum Dare community within the span of 2 days. And you can only use the things that you made yourself, well, to a certain extent. Like, the code for the game has to be all the things that you wrote, all the assets for the game, like the art and the sound and music, everything have to be created by you within 48 hours. So kind of a challenging event. And for me, I try to take it easy. You know, I'm not really using graphics. I'm just using like basic blocks on the screen, but we're trying to actually implement some game logic just to have some fun writing game code, and also to test the limits of the language that I've been working on called Mesh, which is basically a kind of like a Scheme implementation, but it's got some tweaks and changes to it. So it's not really exactly Scheme, but it's a lot of fun to work on. So I like to use that for these game competitions. So yesterday we did manage to make a decent amount of progress where we have some things on the screen. We're working on a dungeon crawler game. Very simple, no scrolling of the screen. You just have what's on the screen at any given time. And the goal is to try to find a particular item on the screen. You can see where it is. You have to go try to get to it, but there will be obstacles in your way. And also fitting with the theme of the Ludum Dare this year, or this event, every 10 seconds, the position of any of the items that are in the screen will change. So we haven't implemented that yet, but we will this morning, I think. So we managed to get everything on the screen, or at least a player and an item on the screen yesterday, and you can go pick the item up. And in fact, I can actually show you that right now. Let me pull up. Well, I probably want to pull up the compiler on that. So let's run compile. That should be fine. Okay, so as you can see, we have the purple thing is the player. The gold looking thing is an item. Colors look terrible for some reason. I need to fix that. But I can use the WSAD keys to walk around. And I can't walk through walls, so it is aware of the shape of the map. And if I go walk to the item here, I can pick it up and it goes away. So that's as far as we've gotten so far, but there was some amount of work that had to happen to get to that point. So we'll continue from there today. We're going to add enemies that wander around. Maybe we can add some traps that you should avoid, not step on. And some other cool stuff. So let's see what we can get to. All right. So one thing I wanted to do before I get too much into it today, over the past couple weeks, I've been working on adding the meta object protocol to Mesh, which is basically a way of defining classes and methods, which is way more flexible than what you would imagine. And I've almost got it implemented. I wanted to use it for the competition, so I might try to see if I can finish it, because there was like one last thing that wasn't working. And if we can do that, we can use it for the game entities and maybe derive some interesting behavior from that. So I'm going to go take a look at the code and see if I can figure out what the problem is there. And then maybe while we do that, some more people will filter in and we can have some fun hacking on game stuff after. So I'll jump into the deps folder, go look at the mesh compiler, and I want to run the tests here, because that's how I'm going to verify that this is going to work. Let's see. Yeah, all right, this is the place I want to be. So let's go to the test folder, modules, test class. Then I'm also going to open up the string tests and just take those out. I got these being, filtered down. Come on. Okay, so back to class. We're going to make this be the only. And I'll try to run this, and I think we'll see that it will fail. Yep, okay. Undefined variable make. Oh, I forgot to import the class here. Okay. Here we are. So the problem I was having. Let's see. Did it say no applicable methods? Okay. No, I think it's just that it can't compute the fields correctly. That's right. Okay. So I think it's something very simple that's going wrong here. So this test, what it's doing, well, is that one passed, didn't it? There's so much output, it's hard to tell. Yeah, one of them passed. I believe it was just verifying that you could create. Why is it still running that? Because I have that there. Okay. Gotta get rid of some of this output. I had to use that for debugging purposes, and now it's just a lot of spam. Classes can be defined. I believe that was successful. Okay, it did not pass after all. Okay, so the idea is that I'm creating a new class called foo that has two fields, bar and baz, and it derives from object. And I'm trying to see if the set of fields that are there are the ones that I expect, but I believe this is failing. So let's see. I'm gonna write it out so we can actually see what it is. I'm pretty sure it's nothing. So display. Unknown. That's even worse. So let's see. Must be returning bogus data of some sort. So let me go to class.msc, the real implementation. And I think it's compute fields that I'm looking for. I wonder if it's something really dumb. So this is sort of the part of the code where the class initialization happens. We determine what the parents are, which is object. Then the direct fields, I should probably write that out too. Just so that we see that it's the value that we expect to see. Precedence list, I'm not too worried about. Then the full field list is the part that is giving us trouble. At this point, it's an empty list, which is not what I want, but at least it returns something. So something's going wrong. Direct fields, direct parents, both of those look correct. And then the field initializers, I wonder if this is messing with anything. That all seems okay. So then we need to find out what's going wrong with the compute fields implementation. Is there not? There we go. Computing fields. So we're in this function now. Class direct fields. All right, so this looks wrong to me. We're trying to grab the direct fields over all of the parents. Let's do this. Unknown. Hmm. Oh, it shouldn't be grabbing foo. Should it? No, it's fine actually. I mean, we do need to grab the fields of foo as part of this. But you know what? Class direct fields must be returning garbage. Field set direct fields. Did I not set that? Add method initialize. It's for classes. Wait a second. So set up the direct class fields based on the init parameter. I mean, right here it should be correct. Though, I should probably check what this is. Debug, init arg fields. Okay, so that's right. Come on now. So then this is iterating over that list of field names. If it's a, oh, okay, is this actually causing a problem? Let's do this. That seems okay. You know what? I bet there's some logic somewhere that's depending on the field name. Being a symbol and not a list that contains a symbol. What is happening here? Computing fields. Is that to create the instance? All right, let me just see what's happening here. To make class foo. We're making the foo class. We're not even creating an instance of it. We're just... I don't know if this is actually the correct thing. Since foo is a class, then does that mean that its field should be bar and bars, or is it the instance that should be bar and bars? But either way, the fields that we get back are totally busted. I don't even know what unknown means in terms of mesh. It's a bad object. I don't even know how it's possible to create that. Unless it's null, which is possible. Okay, so let's get back to looking at where the stuff happened in the code. Mosquito flying around. All right, so we're setting the fields. We're doing the calculation here. Fields, the first time through looks good. I don't know what the difference is here. So direct fields, dispatch generic method, class precedence list. Do I do that next? Yeah, I'm computing a class precedence list next. Then we're computing fields again. I don't know why. And this is where things go wrong. In the test, we only call make once. Class fields is what happens right here after foo gets created. So it must happen all in this section. Computing fields only happens once. I guess the problem is that this is the direct fields. Then after that, we get to the fields we're computing. So the parent fields are unknown. That can't be right. So we're looking at foo, obviously. And then when we start doing the calculation of all fields, class. Okay, we field ref that. Field set, class all fields, and then compute fields is where this was happening. Okay. So we're looping, and the parent fields strangely returns unknown. That should be true because parent is foo, and we literally just set class direct fields. Oops. Yeah, I mean, that's very simple. I wonder if there's something wrong in the execution at this point that's causing the value to get corrupted. I suppose it's possible. I've seen weirder things happen before. Coming back as unknown. It shouldn't be coming back as unknown. Alright, so class field ref. Let's just hook into field ref. I don't know. Oh. I think I know why. How's that supposed to work? Because we don't have an accessor yet. Let me check the tiny CLOS implementation. This is what I'm basing, not close. This is what I'm basing mine on. There we go. So compute fields. Okay, compute slots, that's what they call it. Make sure that my code is not too far away from that. Compute fields. is happening here and initialize. They calculate the class precedence list first. So they're calling class direct slots on each of the items in the class precedence list, which includes the class itself. But by this point, we have not set the accessors of fields. But that doesn't matter because it's supposed to be a class. So it should have class fields and not the actual instance fields. Is it possible that something went wrong with computing the fields of class itself? Well, no, because that actually didn't happen. Not with this logic. So the direct fields of the class how do you even set that? When you call field set, what is it supposed to do? Because there's no accessor yet. Yeah, we may have to pull the ripcord on this. If we hit 7 a.m. and I haven't figured this out yet, then maybe it's not worth continuing. And then we'll just move back on to the game stuff. So what we're doing in the test is we're calling make on class. So we're making an instance of the class meta object, or the meta class, to create a new class called foo. The direct fields of the class would be bar and baz, and the direct parents are object. But it's sort of like, that's not the actual fields of foo. Foo has the fields of a class because it's deriving from, well, that's not really deriving from class. Class is the template for creating foo. So the internal mechanics come from class, but the actual class shape is this. All right, so I guess the thing that proves to me that we can set things, whoops, is that direct parents actually returns something. After we set direct parents on the class we're creating, we can pull it back out. So that's correct. And we set direct fields, and that gets pulled back out fine too. Right here. So that should be fine. When we compute the class precedence list, what do we get back? Foo object top. That's right. So then we get to computing the fields for the class. Then it all goes to hell because this should actually have fields in it, and this is very wrong. This part is right because the two parent classes don't have their own fields, so they are initialized correctly. But for some reason, this is not being returned correctly. I have no idea why. So there's something wrong with that specific leg of the code. Still think we need to inject into field ref. So we need to find what the accessor is. We find the field. So let's see. If equal field name all fields. There's a lot of them because, you know, we're looking up field name quite a few places. And also this is not helpful at all because we're just getting the address of functions of closures back. So there's nothing unique. Oh, excuse me. So we'll just pull car accessor and execute it on the object and see what comes back. That's interesting because I don't see an actual call. Where is it? Okay, direct fields. I don't see the accessor being called here, so does it not find it? Oh, the accessor, yeah. Okay, something's wrong. Let's do this. Wait, I was wrong, okay. This is supposed to be direct fields. Right here, unknown. What does unknown mean? Hey, the Mad Smasher. Talking about a blobber or something like Dungeon Siege or something like Clickpocalypse. It's just like, think NetHack. Very simple. And even simpler than NetHack. Okay, so where is that stuff happening in the code here? Got a lot of output now, so I got to figure out where I was looking before. So compute methods. No, compute fields. Okay, so parent fields, that's what I'm looking for. Parent, what? Did it crash somewhere before then? Oh no, address sanitizer. Cannot apply function to non-list value. That actually tells me something. What are you talking about? Cannot apply function to non-list value. This didn't happen before. Unless I'm screwing up the field ref with the little injection I'm doing there. Nope, shouldn't be bothering it. Not apply function. Oh, I'm calling apply somewhere. I wonder if it's the closure. Something's getting corrupted in the value stack for sure. I don't know what's happening. Like I said, we will pull the ripcord on this if we have to. This is not super interesting to watch, I think. That error only showed up just now, didn't it? Or did it show up before and I just never noticed it? Let me take out what I did in field ref because that was the time that I noticed it. Just comment that out. Yeah, so now it goes away. So what about this is giving it trouble? If I take that part out, maybe it will stop complaining. Okay, and if I put this back in, I think it did the thing then. It crashed. There we go. Cannot apply function to non-list value. Is it because I'm invoking the accessor like that? Does any accessor look wrong? No. Well, that's weird. Wasn't doing that before when I had this here. Let's take that out. I don't know. That just seems like... Why is it that if I print both of them, then it's a problem? There's some freaky logic going on. All right, well, that's all I want to see anyway, so let me just try that. Okay, so parent fields, unknown. Okay, so the value is actually unknown coming from the instance of the class, which doesn't make any sense. Makes me wonder how it could get so corrupted within such few lines of code in between. So back to add compute fields. Yeah, something right here is going wrong, and it's causing the fields list to not be computable correctly. this anymore. So we set the direct fields as the result of the output of this function. And that's fine. I think that all turns out fine. Hold on. No, that's fine. Okay. View the class precedence list. That turns out fine. And it also gets set into the class fine. And it's just that compute fields call that goes wrong. Oh, we're also in the supply right here. We're appending the lists of fields that come back from this map. We see it go wrong here. Yeah. If I was going to pull this out, I would have to, like, you know, start debugging the value stack, and that's just gonna take a long time. So I don't know if it's worth actually trying to finish this right now. I'm gonna have to look at it on my own time, probably. Because I think something is going wrong in the language or the VM here. That's causing these values to come out wrong. I don't think it's so simple as I just put the wrong code somewhere. That something really does look wrong. The last thing I'll do, let me try actually. Right before I call, let's see, add initialize. Right before I call that function, let's just print out the direct fields again one more time. Just in case anything weird happens before. Oh. Wait. So what the hell? You know what? Something about this compute class precedence list is corrupting the field list. Now, let me think about why that could be the case. In the list of class fields, where is it? Precedence right there. Precedence and direct fields are adjacent. Something tells me there's some corruption going on in between those two, and it is a code problem. So add compute fields. Actually, no. I want to go to add initialize. And let's do this. We don't need to compute the class fields before the precedence list. I'm pretty sure. I think we can compute the class precedence list before the fields. What's going on here? 973. And what function is this? Oh, okay. So it actually made progress. That's really strange. But I think we can figure that out. Uh, 982. Collect remaining fields. Excuse me. Cannot apply function to a non-list value. So what is others in this case? I think we're making progress now. I think I may have actually fixed something. Which means I need to look into some other issues here. So coulter of debug others. Okay, that's not going to return anything. Where does others come from? Let's see. Debug field name. Bar. So the fields list is bar buzz. I should actually put this debug on the outside. Let's see, Lispy convolute. No. Okay, let's try this. Fields. Bar bonds. It looks right to me. Hey, Alex. I'm trying to finish up the stuff that I have left on the meta object protocol. I'm almost there. Basically, the class fields calculation was bugged somehow. All right, so the fields list looks right. Current car fields. Okay, so we have null fields reverse result. Otherwise, am I inside of a loop here? No. Yes. Okay, it's a loop called collect. But why do I not see field name for debug? That's right. Bar is the first field name. That's right, isn't it? Fields? Yeah, bar buzz. Okay, fine. So that is what I expected to see. What else is it complaining about now? It's still the same thing about apply. Yeah, cannot apply to a non-list value on line 984. Fine. Others than empty list. We'll just visually debug this real quick. Set remaining fields, filtering the list of fields. Was like deduping field names. If equivalent. All right, so yeah. So for each of those, we're looking at the name. If the names are equivalent, then we set a list called others to contain that item. Otherwise, and we return nil. We say we don't want to keep this one in the list. So after this is done, we can look at remaining. So let me just take this out now. I don't need that anymore. Okay, that makes sense. So now it loops. I'm not going to call that collect. I'm going to call that loop because it's just confusing to me because collect is not a function. Sorry, it's not a label name I usually use on a let. Whoa, 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 whoa. Let's reformat. Thank you. So then, we loop on the remaining fields, which is going to be that last field. We cons the current and okay, what is that second parameter to the loop? That is the result. Okay, so we add that to the list, and then we apply what? Append to the others. So the others list is effectively empty here. What does tinyclos do? Cons append current. Yeah, it's basically the same code. Okay, so apply append. Why are we mapping? Doesn't make sense. What would the other... Oh, okay. I see, I see. Let's see. So these are pairs that are coming through. The field that comes through this list, O. We're going to rename this because it doesn't make any sense. I don't like opaque variable names. Okay, so for each field, which is a pair, we look at the field name, and if it's the same as the current field, we add it to the others list. So then the others list should just be the pairs for the fields. I don't know why it does this. So it appends the current to the result plus mapping cdr across the others, which is going to give you... So what is the value of the... Or what is the cdr of the thing? The default value. Oh. So you make this into a list. Current is... Okay. So others is append. So this should just be a list, a single empty list. So maybe append is wrong. So this should actually be let's get rid of this debug here. All right. Hopefully this will get figured out in a second, but like I said, if it doesn't, we won't spend too much more time on it. Yeah, all right, so this is an empty list being passed into append. But apply doesn't like it. Well, let's just see. Check this out. I'm gonna do begin. Benug. It's early. I'm going to drop in a little break here to see what the value stack has in it. If it works. Yeah, okay. So that's the instructions at the moment. Call stack, value stack. So the value of this list should be here somewhere. Where would it be? Man, that value stack is deep. Apply. No, append. Append is the native function here. There should be an empty list somewhere. Maybe this is why it's complaining. For whatever reason, this param is not there. Oh. Because it got popped off, that's why. Shit. Okay. So I can't actually see what it is. Because it got popped at that point. So that was kind of a useless thing to do. Delete them again. For some reason, append, or no, apply. Apply is not happy with the values that are on the stack. I guess in apply, let's go to vm.c. Let's just hack into the VM. vm.c, op apply. What's there? So it's unhappy right here. Cannot apply non-function. Oh, cannot apply function to non-list value. So if it's not a const, what is it then? Mesh value, print list value. Value. Let's type. All right. So printf the list. I love how this formatter just doesn't try to add semicolons for me. Okay, can you please reformat now? Go. Clean it up. Thank you. Printf. Well. Yeah. Printf. New line. Let's give this a shot. Man. Tools work against you sometimes. The list. Okay. Because it's an empty list. I think that is okay, actually. Yeah, all right. So if it's not a const or not a empty list, because it is valid to pass an empty list of parameters to a function. So that's just a mistake I made. You know what? This could also be part of what we were seeing before too. All right, so the list question. Still complaining? What? Okay, I broke something here. Cannot apply function to non-list value, but that's clearly a list of empty lists. Maybe this is a problem here. Does it need to be and? If it's not a const and it's not empty. Yeah, okay. So is list. All right, cool. That was a problem. So let's just check that little thing in real quick. Where were we? vm.c. Don't check this part in. Bye-bye. But check this in. Apply should accept an empty list as parameter. Okay. So that was a little bug we fixed. How about that? Now I think we're going to make some progress. So class, and this is compute accessor. I believe it's because I'm calling it something else. Accessors. Okay, so it executed all the way through, but obviously this is not right. But I think we've made progress. Direct fields value, parent fields. So let's go rip out some of that debug stuff we got in here to reduce some of the noise. Okay, we're writing out remaining here. We can get rid of that. We can also get rid of the param bit there because we know now that this is okay. We're almost there. I think that we probably did it now. Field name. Get rid of that. Fields. So Barbaz, field name Barbaz, all fields Barbaz. That looks correct to me. So now we can get rid of this. And then this class, yes. And then direct fields. All right, so all the cause direct fields are returning the correct list. Get rid of that. And I'm pretty sure we can just pass through class direct fields now. Whoa, come on now. Okay. Oh, this right here goes away too. Let's just boil things down to what we need to look at and not have any other extra stuff. And CPL, where's that getting printed? Okay, I don't need that anymore either. More visual noise. Precedence, that's all good. Don't even need the whole line. Now, all fields is an empty list, which really is wrong. So go back to add compute fields, and does the result not get returned? Reverse result. Let's do this. When we loop here, we're adding stuff to result. So debug, add result. Okay, so somehow that's not getting called. Add result, really? Why is it stopping? It's getting here. If null fields it's not looping. That does seem wrong. Let's check what the fields list is. So I think I must have screwed up the call to compute fields somehow. I set direct fields here. Well, we're just gonna have to do this again because I don't know what's going on anymore. Class direct fields. We're mapping that over the class precedence list. So the fields list ought to be now this is starting to get weird. Debug fields. Gotta put some of this stuff back. Parent fields. Unknown yet again. Oh, what? Well, because I put it in the wrong place, now I see there's another little issue. Class precedence is not returning the right value. And I think it's this ordering of operations. What happened? Okay, so we're computing the class precedence list. Compute standard precedence list. We do this sort operation. Something in here is corrupting the instance. But nothing should actually be happening to it. Get parents. We don't set anything in the source objects. All right. We're almost there, but we're losing so much time. Trying to imagine what could be corrupting the values. So there's field set, but setting the field uses the accessor for, so instance set. So when I generate the Wompy Rabbit says hi pumpkin, okay. So I need to see what I'm doing when I'm creating my accessors. Field accessors for the actual class field accessors. Yes, right here. So what I want to do is display field. Well, do this actually. Do it this way. Yeah, they have different indices. Oh. Well. Let's wrap it here. Let's say. Debug setting field. Do that. Should be fine. What's the value that we're setting, actually? Yeah, Yeah, that's the right value for sure. Okay, let's do this. I wonder if in one of these debugs I deleted the return of a value somewhere. Ooh. Get precedence. Value unknown. Why unknown though? Very, very strange. All right, seriously, in 5 minutes, we're going to switch back to game coding. Somehow the value changes to something else. Field index. So the index for precedence is 1, field index 1. Just kind of track the setting of that field over time. Yeah, we set it, and it has the correct list. Then we set the Wompy Rabbit asks, is Mesh to C what Clojure is to Java? Mesh is basically a scheme implementation written in C. So yeah, I guess you could say something like that. But the idea is that you would have an embeddable language into a program you can compile to basically any platform that you can do some cool stuff with. So we set precedence, and then we read it back pretty soon after. Getting field precedence. And then right around here, it all goes wrong. Getting field accessors, getting field precedence. So that's for class itself. It's very weird. All right, leave that in. All right. So I need to leave a note for myself somewhere here so I can look at it again. What bugs did I actually fix? Just gonna check this in so I can look at it again another day. So so the class precedence list field value is being corrupted after setting direct fields. That stuff doesn't matter. Okay, let's get back to game coding. So since there's a few more people here, let me just show you what we are working with so far. I will run compile on the game itself and then run that. So very, very basic dungeon crawler type thing. You can see we got a little bit of a map here. Ignore this part. I was trying to like see if I can carve out the whole shape. But the purple block on the screen is the player. So if I can use the WSAD keys, you can see me walking around. I can't walk through walls. Like it actually respects the shape of the map. And then this gold thing here is the item that you're supposed to pick up. So I just picked it up. I can keep walking around. All good. So what I want to do is try to implement the actual logic for randomizing the position of the item every 10 seconds. So there's a couple things that I would like to do as part of that. First of all, let's see, where is the item position randomization at the interval? Okay, so show a timer gauge at the bottom of the screen. Pick a new position for each item. And ideally, unique position for each item. But I'm not going to worry too much about that because it would make the algorithm a little bit slower to have to keep recomputing. But maybe it's not, okay? Also, I need to keep a list of all valid item locations. So I guess that's the first thing I can do is when I load in the map data in world. So I create the world. Now we're not going to generate anything here. Tiles. All right, so at this point, scan the world for... Actually, we can do that here, probably. Yes, org mode. This is all Emacs here. All right, so scan the world for valid floor positions. So we will do a simple little loop here. Let floor positions. I put that in an array so I can actually keep track of the length easily. Probably. So, we're going to add a new thing here, floor positions. And then when we create the instance, we're going to add floor positions. I don't have a thing for... I need to know how many there are. I don't want to have to keep that information separately, but I suppose... It wouldn't hurt to have the concept of a position list because I might actually want... you know what? Let's do that. I'll tell you why. Because I might want to have different kinds of positions. So define record type positions. Trying to imagine if this is the right... I mean, usually you don't have a plural name for a type, but whatever. Let's just go with that for now. Positions... array. And then, well, we don't need a length, do we? I suppose it could be a list, even. It doesn't have to be an array. Length. Okay. So what we'll do is create an instance of make positions. And then we can just put a list into it and length. We're actually going to create that. So let loop and tiles. I don't know if tiles is really the right name for that either, but remaining tiles. Then positions. and then that can be an empty list, and then length of 0. Then once we're finished, we're going to create an instance of that. So what we're going to do is just loop through all the tiles. So if pair tiles, well, let's say if null, then we're going to return this make positions. Okay, so we're going to put positions here, and we're going to put length here. So then otherwise, we're going to check the type of tile that the current tile is. So if equal or equivalent, car tiles is 1. Or actually, for a floor position, let's call it, if it's not 1. 1 is a wall. 0 is a floor. We might have other ones as well. So at least for now, this is the logic for saying that something is a floor position. And I might actually, you know what? This needs to be a higher order function. So predicate. And the predicate we're going to pass in here is going to be that one. So if predicate par tiles, then we add it to the list. If it returns true, we add it to the list. So we will loop, and we're going to oops, let's do this. Const the hold on a second. We need the actual XY position. So we have to keep track of that as well. And we don't know what that is without looking at the world data. That's fine. Let's just keep moving. So we're just going to put the car tiles on here. This is wrong. Let's just get the algorithm written first, and then we'll come back to make it right. Now, we don't want to put that in that parameter. We want that to be the second parameter. So we're going to say cdr tiles here to get the remaining list, and then that's going to be this one. And then we're going to add 1 to length. So this is our recursive loop, and this is going to build up the list step by step. So then what will happen ultimately is that, so if the predicate is false, we need to continue looping also, but we need to do a different thing. So cdr tiles, yeah, I think we can simplify this actually. So what we'll do instead is call loop here, cdr tiles, and then if predicate, or in fact, let's just eat this, delete that. I feel like I'm holding something. Yeah, I want that. Okay. Loop cdr tiles, and then we're using the predicate to, let's pull this linked out. Did I do the right thing there? That was wrong. That also seems wrong. Okay. Yes. All right. So if predicate car tiles, we're not going to call loop here. We're going to just use the cons. So const car tiles to the positions list. And then here we just return positions. Okay, so let me explain what's happening here. We're always going to loop to the next step, or to the next tile position. So this loop cdr tiles is just going to get the next tile in the list, or I guess the remaining list. And then the new value of positions will be either, if the predicate is true, we const the current tile, or whatever the value would be for that, onto the positions list. Otherwise, we just can continue with the positions list. And then we always increase, oh no, we do not always increase length by 1. That's sort of the reason why we should do separate loop calls. Okay, so let heap, let's do this. Wompy Rabbit says, where, how is game state stored? Just in module level variables for now. Nothing special. Got to keep it simple for this type of thing. All right, so if keep, then also if keep. Yeah, this doesn't feel super clean to me. I suppose I could calculate the list linked at the end, but whatever. I don't want to have to do that. All right, so that's ugly, but it'll work. All right, so this looks right to me. Now, I can also call this gather positions. And then when I create world, I can say floor positions is gather positions. Lambda p kind. All right. So basically we're calling gather positions. We're just saying that if it's not tile kind 1, then treat it like it's a floor position. And then we have that information stored for the world. Then we can get rid of this piece of the logic. Now, I need to fix this. So we need to know the actual... Do we need to know the actual? Because it could be just the index. Yeah, we don't need to know the XY. We can just say what the index is. Because I can use the index to find the location to set. Or I can calculate the XY position based on the index. Okay, so this is what we'll do. Index 0, yeah. We'll always increment index. And then instead of saying we're storing card tiles, we're storing the index. So the position is technically an index into the grid of tile positions. So let's run it and see if it crashes. Expecting 2 arguments. We got 1, line 49. Not in this file. Why is there so much? Okay, I think it's because I was trying to add rendering for something down there. Line 49 must have missed something. Oh, it could be here. Expect 2 arguments, got 1. Equivalent tile kind. It should have told me it was a bad variable reference. Maybe it's not referring to this one. What about game? Can't be right. Has to be here. Yeah, so it's this line. Not does not require 2 parameters. Expected 2 arguments but got 1? What is happening? For equivalent? It's not even printing it. Okay, something's wrong. Oh, is it gather positions? Of course it is. That's a bad line number. There we go. I smell an infinite loop. So this loop must not be terminating. That's why. Remaining. All right, whoops. Tiles. Am I referring to tiles? Yes, that's bad. Remaining. Bad. Remaining. Okay. Okay, there we are. So it won't look different. But at least, well, you know what? Maybe I should write out that list just so we can take a look at it. So, display floor list. And we're going to display the positions list of world floor positions for world. And then display a new line. Okay, so that's not the whole world. In fact, I probably should reverse that list when I return it too. So right here. Okay, so 35. That seems right because I think the width of the world is what? Let's see, game, the world width is 34. So since it's 0 based, then what we saw is if this is 0 and this is 33, that means this is 34 and this is 35. So 35, 36, 37, 38, 39. So these fields right here, these floor positions. So that's actually right, I think. Oh, this is going to be treated as a floor position, and the guy could, or the item could end up here. So maybe we shouldn't do what I did there. That's fine. Maybe that's part of the charm. World one.text. Let's just go change these all back to ones so we don't end up with any trouble. Okay, so now we shouldn't have it show up anywhere that's unreachable. So let's go and we have the positions list. Now, I guess the next thing to do I think I should put that into another module. So let's go to positions.msc. Define module erratic positions. And then we're going to put this positions definition here. Also the gather positions definition. We're going to take that, put it here. And then we're going to go up here and import this module. Pull in erratic positions. Reason why I want to do that is so that I can refer to it elsewhere. So I would like to make a function define position to position. No. Position to world. How about that? And we have a position. And then we need the world itself so we can take the world size. So to calculate this, I think I'm going to do a plus. Did I not already make a conversion of this somewhere? I feel like I did. Was it in world? Yeah, it was basically this. So y is the floor of oh, let me just think through this and not do it the wrong way by copy pasting something that I'll have to work my way through. So we have an index. We're going to return a const pair. The x would be the modulus of position by world width. Because if that position is 35, then I want it to be 0. Because the world width is actually 34. Should I make that... Should that be -1? No. That's right. Okay, so if... yeah, okay, that's good. And I think that the Y position is just going to be the division, right? So we're going to divide position by world... no. Yes, by world width. Because that's sort of like the scan line. So if it's 35 and you divide that by 34, then it's a little over 1. So I need to do a floor of this so that it becomes an integer again. So that should work. Now, the point of that is so I can go to game, and I need to keep track of how much time is left before we do a randomization of items. Get this out of the way. Define randomize items. Let's just run it. Excuse me, run it once and see if it puts the item somewhere else. No, I'll send you this. It's going to shadow the actual item list. I think I should be storing these in a record type and not just as variables. So we'll just have it be a function like this for right now. Randomize items. So I need the world. The position list from the world. Let floor positions of world floor positions for world. Let's not even call it floor position. Let's just call it positions or item position, because we might expand on this a little bit in a while. I might actually make a special number for item positions. So then, for each of these, for each item, so first of all, let loop so for all the items that are there, we need to loop through all of them. Oh, you know what? I could actually remove the position from the list to ensure that it is unique. But I would have to... I could do that. Not terrible. A little bit inefficient, but it's not terrible. Because if I had like a list set function, then I could just run through and just update the list up to that point. Kind of like that. Okay, so let's do that then. Positions. We'll just start with this. So now inside the loop, we're just going to go through for each item. So if null remaining, then we need to update the items. Let me think about this. Do we need to do anything when this is finished? Or are we just updating the item positions in place? I think we're updating them in place. So we can check pair instead and just have the body be here. So for that pair, or for the item, we could say item. Let's see. We're going to compute new position. Position. Well, we haven't picked it yet. And to also get a random number, we need to know how many values there are in the positions list. Nope. Oh. I actually need to grab that first. So let since I don't have a let star, I have to do this kind of thing. Okay, so item positions, world, floor positions, world. Now we have remaining items, and then we have positions list of item positions. We have num positions, length item positions. I guess length is not the right name. I would rather have it be count. Okay, so now we're gonna call that count. So then we have the number of the items left, the positions left, the number of positions left. So if we're still in the loop, we need to pick a position first, which means getting a random number. So position to world. I think I have a rand function. Let's see. Let's go back into VM rand. Math rand. So it's rand that takes a range. Yeah. Okay, so let's go back into game. Rand. I'm pulling in math here. No, I need to pull in mesh math. So rand of num positions. So we're just going to pick one randomly from the remaining number of positions. Position to world. We also need the world itself. So we're going to say world here. And that's going to give us back a new XY coordinate for the item to be in. So then here we can set, well, no. Item X set car remaining car new position. And we're going to do the same thing for the Y axis. Maybe position should have just been a const pair to begin with. Could have made things easier. So then we're going to get the cutter of the new position here. That will set the new position. But we also need to loop afterwards. So we're going to loop here. Cutter remaining. And so when we took that position, we need to remove it. Hi, Zane. Yes, did I mention that on the stream? I can't remember. Maybe I didn't. I don't remember. But thank you. Okay, so I need to remove that position we picked from the list. So maybe what I need is like a take function. Just take an item out of a list. So define list take LST index. So let loop. As you see, there's a lot of just, you know, named let looping going on in my code, but that's sort of the point, is that Scheme just makes it really easy to do that. Okay, so let loop and result is empty list, and item index is 0. Okay, so we're starting with that. Then what we do here is if null, we also need remaining LST. And we just return the result. Oh, we don't return the result. Ooh. We're not mutating the list. We need to return the result and the new version of the list. Yikes. Maybe that's just 2 operations. But you would have to loop over the list twice to accomplish that, and it feels a little bit wrong. I mean, the funny thing to do would be to const. You're basically taking the item you're looking for and just putting it on the front of the list so it can be decomposed by the caller, which I suppose is probably fine. Doesn't feel super easy to use though. Once this stuff is written though, it basically forms the basis for how the game logic is going to work. So it's worthwhile writing all this stuff, I think. Okay, so just going back to this, when we pick a position, we actually need to take it from the list. So position world, rand, num positions. This is actually wrong. This needs to be effectively the list take that we were looking at before. And then new position. I may have to do a nested let here, which I'm not crazy about. But I don't have a choice at the moment. Technically, it would be a nested let in Scheme anyway, I guess. We're going to use the positions list, and we're going to say rand num positions. Okay, so we got the result of taking an item from the positions list. Now, where are we? There. So what I want to do here is decrement the num positions. And then we need to do this part. This now can be car take result. That will be the position where you have taken. And then when we do the loop in the end, We say footer remaining. We also say the footer of the take result. And then the num positions. Well, I guess here we could do num positions -1 because we already know that we've taken a position. So we can not even have to do this mutation. So if there's still remaining items left to take a look at, then we take a random index from the positions list. And that is going to be, is basically changing the list such that the desired item is at the front of the list. So then in this code, we pull that item off the front, which is the position, and then we calculate the new position based on that. Then we can set the item position based on that position. And then we loop, we go to the next item in the item list. We also take the rest of the positions list that we have moved around, and then we subtract 1 from num positions. So that should be enough to do that. Okay, and I think I can generalize this function to use the same logic for enemies as well. So I'll do that after I finish writing it and we see that it works. So now we need to just finish this list take implementation. And the idea is that we need to find the desired index. So if null remaining, null remaining, we return the const of, yes. Found is F. If the item index is outside, yeah, you shouldn't be able to find it. Well, no, that's not even true. Kind of hard to say what a sentinel value would be for not finding the actual item. I guess I would need to have a Boolean instead. So found is nil. Item is nil. Okay, that's how we'll know. So if null remaining, then this is the in case. So if found, then return const item results. Otherwise, return the original list because we didn't make any change to it. But I guess that doesn't tell the caller anything. I think it just needs to be an error. So display bad index. Use error. We don't have error yet in mesh, so we just have to write something out and hope that the user realizes they made a bad issue. This is my code. I don't have to worry about it. Okay. So if found, we return the const of the item and the result. Otherwise, if we still have items left to process, then we loop. We need to do a check to see if the current index is the right one. So if equivalent index, item index. So if it's the one that we're looking for, then we don't loop. I think we could return directly from this point. So maybe we don't even need this case, actually. So if we happen to find the index, we can just return cons of item. We also need to do cons of result and remaining, because we're trying to join those two pieces of the list to remove the item. So put the, wait, are remaining, footer remaining. Okay, I think I can simplify this now. So this is the index, so put the item at the front of the result and remove it from where it previously was. So that's if the... I'm gonna find a way to make this nicely general so that we don't have to do any special casing, but I don't know if I'm going to be able to. I might have to set the cooter of cons pair, because I don't want to have to call append a whole bunch of times. This seems really inefficient to do that. And I don't have a set cooter right now, but I can add one pretty easily. All right, so if it's the index we're looking for, we return the list with the item, that item, at the head. And then the result we assume is a list of all the previous items that we looked at that weren't the index, plus the items remaining after the current item. But if it's not, then we need to continue iterating. The easiest way would be to do this, which maybe we'll just do it and see if it is a performance problem and just leave it as it is. So we will do append result and list are remaining. So what we're trying to do is build a new list. We actually want a new list all the way up until the point where the list gets changed. You know, it's kind of a waste though, because we don't want to make a new list until we find the item. Is there a way we can simplify that part? Maybe that's the way to make this cheap, because if we get to this point, maybe we should just return the original list or throw an error. So maybe that's the ticket. We'll just return nil. So if we can't find the index, then we just bail out. Otherwise, we need to loop. So this is the point where we need to loop. So if it's equivalent, then do this. If it's non-equivalent, keep looping. And to keep looping, we need to set all these things up here. Do we even need result? I think that we might need to just generate it on demand here. Because otherwise we're just creating a bunch of cons pairs for no reason. I think we need to do that. So the loop would just be, if there's no result then, and there's no found, and there's no item, then we're back to just remaining of the list that we're processing and the index. Okay, so that's much simpler. And then we just do footer of remaining, and we'll just increment the index. And we're not going to do this append, I think. Okay. So then, looking at this logic one more time, we want to append to the front the item that we found at the right index. And then we need to const that with the result items up until this point as a new list with the remaining items. Okay, so basically we just need to have like a way to copy a list up until a particular point. So how would I do that then? Because I'm kind of already there. Let me think about that. Yeah, what's worse, having to re-loop over the list or building a bunch of const pairs for nothing? Well, let's assume that in most cases, we actually will have a result. Maybe we won't. Maybe we shouldn't optimize for the case where we don't have a result. Okay, okay, I like that logic. And this is not result, technically. Okay, let's just do that. Okay, so here we're gonna do append, result, list. Yeah, we have to do looping on that anyway. Whatever, it's fine. This is fine. To do use set coulter to make this faster. Algorithm design. Okay, so append result list the R of remaining. So that's going to give us the result list, the remaining, and the index increase. And then once we find the item we're looking for, we just const that first item on the list with the result and the remaining item. In theory, that should work. I hope it does. So now we want to verify that we're using this correctly. That's a lot of code we wrote. Hopefully it actually does the right thing. Gonna find out real fast here, so let's try to run it. Okay, so line 26 of world, I'm guessing, 26, gather positions. And we need to export that from the positions file. Oh. Export. We also need to export this position to world function. And I think we've got an, oh, no, fine. All right, we haven't called that yet. I actually want to call it one time in game to give it a shot. So items has already been configured by this point. We can just go right here and call it once. To do, remove, randomize items. Okay. Undefined variable positions list. Oh. What did I call it in position? Oh, okay, I did not import that library here. So erratic position. Let's get things aesthetically pleasing to me here. Undefined variable rand. Rand is here. Where did I? Is that my math? Rand int. Okay, that's what I called it. World width. Line 26 in positions. Ah, crap. Yes. Actually, let's do that. We don't need to call world. We can just take it as a parameter. That's much better, I think. Why would it need to know about the world? It just needs to know the width. So then back in game, position to world, we will just get the world width because we already have a variable for that. So we don't need to access it. Undefined variable floor. And line 27. What about in position? Oh, floor. Okay, this needs to have math also. So import mesh math. Oh, look at that. It actually worked. And I can pick it up. So it knows where it is. And let's try this time. See if it shows up in a different location. Yep, look at that. It's right there. Cool. So then if I go to game floor, where is am I writing that out? Is it world floor list? Okay, let's just get rid of that. Need that. All right. So in that case, I would like to go back into game and let's generalize this randomize function. So then the way I would do this is randomize positions. I'll give it the items list. Now, I could call this entities. Ooh, I also need to have the right positions list. So positions, entities, positions, setter. So then I could get rid of this outer thing here. So calling this positions is a little bit wrong, I think. I need to call it something different. So I already have a positions variable. Valid position. Okay, so let's call that valid positions. And item dash positions. Okay, so valid. So we got valid positions there. Entities. All right, so items, and then I think what I had here was world, floor, positions, world. And then the setter needs to be a function that does basically what these two lines here do. I'll call that here setter new pos. And then this could be a lambda new pos, where we paste in those two lines. And that basically sets the new item position once it's been given. So now we can try it and see if the code still works. All right, so undefined variable remaining, where? Ah. It needs to have the item also, so item. I suppose I could just give it the X and Y directly so that it doesn't have to digest it at all. Probably a better API. So car of new pos. And let's just copy that, and this will be the footer. All right. That should do it. Entity. Oh, I think it's a car remaining. I think that's right. That's not the original position. I'll start it again. Okay, cool. So we've generalized that function. That's kind of nice. Let's see if we can check some code in, then I might take a break for a moment. So in game, we have the randomization function. Let's see, positions. We did that. So a timer gauge, we don't have that yet. Pick a new position for each item, and it is unique by the way that we wrote the algorithm. And the next thing we'll do is the timer and actually randomizing the position whenever the timer passes. So I'll do this too. Wait, hold on. All right, so this is add item randomization algorithm. That's pretty much it. Valid position gathering. All right, got that pushed up the repo. I actually have the link to the repo pinned in the chat, and I think it's also in the description if you want to check out the code. So I'm going to take a 2-minute break, and I'll be right back, and we're going to go start getting the timer implementation working so that then we can be randomizing the position of the items every time the timer passes, and then that should form the basis of the game logic going forward. So I will be right back, probably somewhere between 2 to 5 minutes. Okay, see you in a second. All right. So let me see here. Grab a little hydration and food. Despite the detour for the class fixing work this morning, I think we're making some decent progress. Hey, Alex. Are you hacking on anything tonight? I say tonight because it's tonight for you, but it's morning for me. All right, so got to keep track of the amount of time that's passing. We have an update function we haven't used at all yet. Got some paint code going. Nice. Alex is working on a rasterizer in. All right. So in the update function, we need to keep track of, let's see, define the randomized timer, or time until randomize. So we'll just say that's in seconds. And the time delta, yeah, I think time delta is in seconds, but it's a floating point value. So we have time until randomize. And so let's just say set time until randomize is time until randomize minus time delta. If less than 0, well, time until randomize is less than 0, then randomize, we'll do the whole randomization thing we had seen before. So let me move this function down closer to where render is. Yeah, there we go. So we had that randomize function right around here. Just steal that, move it down to the begin block right there. Delete that, pop this back into alignment. Now, I'm actually going to set, we need to reset the erratic time right after that. So set time until randomize, random interval, randomize interval. Okay. So let's set a variable for that too. Time until randomize, and then randomize interval. What I actually want to do is set this to like 2 seconds at first, just to try it out. So randomize interval. Now let's see if it works. It might be just that easy. Ah, there it goes. Boom, look at that. It's moving around. That was pretty easy. That's what happens whenever you implement behavior piece by piece in layers. Eventually, it just makes it easy for things to happen the right way. Okay. So if I were to catch this item, uh-oh, can't catch it. Uh-oh. Ah. Come here, come here. Boom, got it, all right. So the good news is that when I pick up the item, it doesn't actually break the game. whenever the list is empty, the item list is empty. Good. Nice map, thanks. I need to work on it now. Now that I have the ability to put items in the world. Yeah, that is a game, but it needs to be, so the interval is going to be 10 seconds. Let's just set that up. And then we need a couple things. One, we need a timer meter at the bottom of the screen that sort of lets you know how long you have until thing happens, which that's, you know, fairly easy to implement. And then we need a more fleshed out map. And then we need some other types of items that are useful for like evading traps or like keys to open doors, that kind of thing. So let's see. Let's go to our world for a second. A couple things I want to do. First of all, any of these choke points, like right here, they need to be doors that could possibly be locked. And that locked door position could also change every time, which would be pretty funny, actually. So everything about the position of things in the game changes, and you have to deal with that every 10 seconds. So maybe you just have to get lucky. All right, so let's come up with a list of types of positions we might want to deal with. So I'm gonna go back to game, or maybe world. How about that? Because world is where we're gonna gather all these originally. So the positions we're gonna have are 0 is floor, 1 is wall, 2 is door maybe, 3 is item, 4 is trap, 5, I mean, enemies could go anywhere. So maybe this is all we really need right now. So maybe for now there's only one kind of trap. And I think like corridors would be a great place to add traps. So if we were to imagine that, let's split this. Well, no, we don't want to do that because we need to see the whole world. We could put it down here though. So let's put game.msc, no, world.msc. And then up here, we'll look at the world1.txt. So let's flesh out this world to make it a bit more interesting and add some of the things we talked about. So door would be right here. Kind of hard to visualize this, but it'd be nice if I could make this buffer color all of the things differently. But I don't want to have to figure out how to do that in Emacs right now. Or do I? I mean, it's simple regexes, and it would help a lot to visualize what the... Okay, can I spend like 10 minutes on that? Let's see, Emacs, font lock. Font lock add keywords, haha. 10-minute timer started. Thanks, Wonky Rabbit. So we're in this mode right now. And I think if I just do this font lock add keywords, I should be able to just throw some regular expressions in and pick certain faces for this. I don't really need a hook. I can make a custom mode, but that just seems really overkill for the amount of time I've allotted for this. So here's what I'll do. I'm gonna go in this, well, I need this. So let's do this in the org file. So Emacs world editor config. So let's drop this in org mode. Then I can edit this outside. We're not going to add a hook. We're just going to make this a bit of code that can be executed. So, whoops. Okay, maybe we'll do it. So this is what mode? I think it's text mode, right? Just plain old text mode. Text mode. Mode. Is there a text mode? Yes. Let's go with that. So text mode hook. Should be one of those. All right. So now we're going to just put this lambda in, font lock, add keywords. Don't need all of that. And let me make this a function too. Defun erratic world highlighting. Oh, I'm writing scheme again. Set up erratic world highlighting. Okay. And then we're just going to add this as the function. So set up erratic world highlighting. We want to make sure that when I keep rerunning this, it gets the newest version of the code. Oops, want that. Okay, there we go. So font lock warning face, let's say 1. And what is font lock warning face? Describe face. That would be great for a wall, I think. So maybe make that, oh, that's right. Okay, so maybe let's do this and this and go up here in normal mode. It did not work. Let's see. Text mode hook. Okay, that function is there. If I'm in this buffer, setup erratic world highlighting. So, oh, okay, interesting. Is font lock mode on? Yeah, it's on already. So why aren't you doing the right thing? Oh, is that the group? All this add keywords business, I think, whoops, wrong. All right, I need to look at the documentation for, can you explain to me how I'm supposed to do this? No, I don't want that. Oh, nil? No. Let's look at the docs for font lock add keywords. Does it give me the information about this? Mode keywords. Hold up. I need to set a, no, okay. All right. Keywords for mode. I mean, I want this to be for text mode. Is that a symbol? Okay, symbol. Okay, cool. Text mode. I don't want it for every mode. Or a major mode command name. That's good. Mode should be a symbol. Keyword should be a list. See the variable font lock keywords. List of keywords and corresponding font lock highlighting rules. There are two kinds of values, user level and compiled. User level keywords list is what a major mode or user would set up. Normally the list would come from font lock defaults. Okay, well that's not there. Each element in a user level keywords list should have one of these forms. A matcher, matcher sub-expression, matcher face name, matcher highlight, dot. I see. I think that I need to get rid of this. And just make it very simple. I don't know what that T is, though. Highlight should either be match highlight or match anchored. Single items, for example, each instance of the word foo, typically only highlight or only match highlight is required. Match highlight should be of the form sub-expression face name override lacks match. Face name is the expression whose value is the face to use. Okay. Got any examples here? An element of the form highlights, if not already highlighted, foo in the value of variable. Foo or bar. Oh, okay. So can I just do like 1 here? Can I just do, like, 1 here? All right, let's try normal mode again. Come on, man, work for me, please. So font lock keywords. So it's actually not being updated in this buffer, is it? Or is it in text mode? Font lock keywords. Is there a variable for that? Text mode font. Emacs text mode font lock. Seriously? Come on now. Add keywords. Okay, that's super simple. Font lock, add keywords. Let's follow this example because maybe that's much easier than what I'm trying to do. Font lock warning face. And then I'm gonna go up here and just run that directly. Let's kill the buffer and reload it. I just feel like it should be working and it's not. What if I add another? So 2, describe face, font lock, type face. What if I just do this? What if I just do this? No. It needs to have a value. Is that right? Oh, I somehow lost the symbolness. That's very weird. Let's see. Keywords. What else can we put in here? I feel like maybe for some reason font locking is not on in this mode. It should be on, right? Text mode font lock. What happened? Oh. So you have to set font lock defaults to nil? Okay, so your following code should work. Text mode, hook, lambda, set queue, font lock defaults. All right, so let's try that. Back in our buffer here. We need to do this to text mode to make this work correctly. So let's try text mode. Oh, look at that. Okay, it works now. That makes it way easier to see what we're trying to do. So then, let's see what else we can add here. So we have world.msc. So we have wall, door, item. So let me try expanding on what we've got a little bit here. So maybe we want a few kind of choke point situations. So 1, 1. So that would be a door here. 0, 0. Well, no. 1, 1, 1, 1. 2. Maybe a bigger room. Would also be nice if I could make some Emacs Lisp code to make it easier to edit these cells, but So this could just be a little room. So item locations, we can set up 3. Describe face, font lock. Function name face, font lock, function name face. That could be item. Okay. Text mode. And then I'll put, what, a 3? Okay, so that does make it the right color. So where else we would like to be in here? And then in the hallways, it would be cool to have some traps. So 4, 4, 4, 4. And let's add something for 4. Maybe like a purple color to make those stand out a little bit. Or maybe a reddish color. Error. Font lock. Warning. Maybe that keyword face. Obviously, with a different theme, it's going to look different anyway, but go back to text mode, and then we got our 4s showing up now. That's cool. So then we have a door there. Maybe we want some more rooms that spawn off in this direction. Maybe some winding paths a little bit. Winding paths are bad for the player because they could mean a lot of traps that have to get through. Maybe you can't even make it through. And then I can maybe go off in this direction a little bit. I don't have any real, thought process behind what I'm doing. I'm just kind of sketching some things out to see what might be cool to play. Ultimately, I want to fill up this whole space with pathways. Maybe right here it could be an item position. That'd be pretty funny. Put like a trap here, 4, and then 2 possible item positions. Was it 3? 3, 3. I think it's going to be pretty cool, actually, once we get it working. So in this big chamber, the item could be, you know, various places around. Curious to see what this looks like. Maybe let's give it a shot. And this is good now. I'm glad we wrote that, because that makes things way easier. So let's go to compiler. And then let's go, well, let's run it and see what it does. All right, so we got more of a world here. And obviously you can't see the positions where the item is going to end up. And it takes 10, well, we need to update the code for moving the item around so that it uses only the item positions. So let's do that really quick. I also want to increase that interval just to see it pop up in the right place. So interval, maybe every 1 second it will move. And then we'll go into, I think, world. And for item positions, we're going to add a special one. Item positions. Take entities out of here because it's not going to be here. We're going to run gather positions. And it's going to be specifically looking for tile number 3. Or tile kind 3. So floor positions we might not actually need to gather. But we'll figure that out. So that should gather the item positions. Now we need to go back into game.msc and randomize. Where is it? Right here. And world item positions instead. So let's go back to world. I think I need to add a field for that. Item positions. Let's run it. Okay, let's see if it pops. Okay, it looks like that's going, whoa. Went to a location that I don't recognize, unless it went right on top of the player. Cool. Looks like it's working. Let's see. So we now have it constrained correctly to the set of positions that we want in the map that we've designed. So what else do we do? I mean, let me go to our to-do list. So show a timer gauge, we need to do that. Now, what was the other thing that I was thinking of just now? We also need to make sure we don't pick player position. So, oh yeah, that was the thing we wanted to do. Make sure that the position of the item is not within some distance of the player. Maybe I won't do that. It could show up right next to the player to make it easy, but I don't know. Is that the right thing to do? We also should add some other items, like keys and stuff, because we're gonna have locked doors. In fact, we should be able to draw those doors. That's kind of nice, actually, because what I can do, that's really awesome. Check this out. So since we have... in the world, so we have a door right here on position 2, right? We have a door... or right here. We can have a door right here. We can have a door right here. So I can find all the positions of where the doors are supposed to be using the same position gathering logic, and then create some number of doors and then some number of keys that are associated with those doors. So maybe no more than like, 1 or 2. I don't know. Can't be too many. Wompy Rabbit says, what video of yours has the best intro to your use of org mode for project management? I don't know. In the original Emacs from Scratch series, probably video 5 or 6, one of those talks about org mode for task management. So that's probably it. But I don't know if I go very in-depth for project management, because I don't do anything super elaborate for my own project management. I'm pretty bad about that. I kind of just fly by the seat of my pants. And maybe we want to put some more trap locations in, like right here, or in these 2 locations. Maybe we can, pepper in some traps that you have to dodge around. And they're not going to have traps the whole time, and those traps will move also, which could be pretty fun. All right. Making some progress. So the timer meter, we can add that really quickly in render. Render the randomization timer. So what we'll do is have a minus of the randomization interval. No. That we're going to divide the time to randomize by randomization interval. That will give us a 0 to 1 value for however much time is left. We want to multiply that by some width, like let's say maybe 200 pixels. And then we're going to use that to draw a rectangle. Rect. Okay, let's go into player, steal that rectangle drawing code, rect. All right, pull that out, go back down here, paste it in. And then we're gonna have a fixed position to start with. So we will say, where is the beginning of the world position? It is world X, right? Okay, we could try that. Just put it there to start with. World X. Also need window height. Let's say minus 150. Let's see how that looks. Take that out. And then for width, we need this, because that will be the bar width. I could write out a number also, but let's just see what the bar looks like to start with. And the height of the bar, let's make it 75. And then the color, let's just make it RGB 25500 to start with, or let's make it hideous. And let's see what that looks like. I also want to do a max of 0, because it is possible that the time to randomize is below the randomization interval. So let's just do a max on that. Okay, so smart. Time to randomize. What did I call that? Time until. Randomization interval, randomize interval. Okay. Really need some code completions in here. Okay, there you go. You see it? That's for 1 second. I need to make it not so big. So let's make it 50, and let's push this to window height minus 125, I'll say. There we go. So do we know how wide the world is? I must know how wide it is. World pixel width. I could also set the position. Well, if I did that, I'm trying to think of like the best place on the screen to put that. It's okay right there, but I kind of feel like it needs to be somehow more visible. Let's put it to a longer interval. Like, let's say we could do 10 seconds, but maybe 5, just to make it take a little bit less time, more time. Nice and smooth. It must have landed right on the player position. Need to fix that. You know, I can do this. So there's 2 things I want to do. Well, first of all, let's make sure that the item doesn't show up too close to the player. I do want to do that after all. And we'll take this right here out. We don't need that anymore. Okay. We did that now. Update the randomization timer. If it's time to randomize, do it. So we might need another lambda for acceptance. So we're going to call that a predicate called acceptable. So before we use a position, maybe right here. So if acceptable, yeah, okay. I think I can see how that's going to work. New position in the world, take result. Let's put it here. If acceptable, our new post. Footer, new post. Then we can go into a begin block. Oops, what key I pressed to duplicate like that? Okay, so this means if the position is acceptable, if it's not acceptable, which is where we'll go right here, we're going to do another loop. Actually, let's just steal this one. But we're not going to take the coulter remaining, and we're not going to use the take result. We're going to just loop again with the same set of positions. And the same number of positions. I know it seems a little bit weird, but I think that's the right approach here. If the position wasn't acceptable, run the iteration again for the same item and same positions list. Okay. Randomize positions. And, you know, it'd be nice if that was optional. So, acceptable. I don't think I have an optional parameter in mesh. If not. Well, okay. How about this? Or if the value that gets passed in there is just true, then automatically use it. Otherwise, if it's a function, maybe there's a better way to do this. I can just check if it's a function and then execute it, but it's fine. Yes, let's not do that. If function acceptable and no. What a mess. All right, so if it's not a function, or if you call it and it returns true. So if it's not a function, just go ahead and accept it, because we want any value that shows up there to not make the loop forever, I guess. Okay, so let's try this. Now for randomize positions. Items, we want to pass in a function, a lambda here, x, y. Yeah, we're just trying to check the position of x, y. So we have to check to see if it's nearby. So, and so less than 3. Okay, let's use this. We're gonna find a function called is close. Player xy. It's close to player. And from here, we'll do the same kind of, well, not actually what I want to do. Let's wait a second on that. Let me just try to write this out, and then we'll generalize it to a function if necessary. So, right, I think that was it. It's the check for the value. So minus x player x. Okay, so player x player. So the player x position. What we want to do, let's take a look at the map real quick. So let's say the player is right here. I think like a 5x5 zone around might be enough. So, or not, yeah, 5x5, like centered where the player is, 5x5. You subtract 2 or 3, I don't know. Subtract 2 from the player position or add 2 to the player position. So if you subtract the player position from x, that assumes that player position is greater than x. Trying to find a way to make this simple. But let's just do it the dumb way first. So if you subtract player X from X, and then it's greater than 2, then it's acceptable. This has to have positive magnitude. If, can I do the absolute value maybe? So if X is greater than player, so let's say that, this is what? 0, 1, 2, 3, 4, 5. So 3 minus 5 is -2. That's fine. So we just do an absolute on this. So if the absolute value is greater than 2, then it's not close. I could say less than or equal to 2. Oops. And can I do the same thing for y? So maybe I can I want to be able to test this out so that I know that the behavior is going to work before I actually start depending on it. Okay, so if I go up here, acceptable. Two. Okay, yeah. I'm gonna call is close to player XY. I do want that so that I can log it. I want to be able to see what the result looks like. Okay, so let result. And then in here, whoa. If result actually, let's do this another way. And then we'll write out the values. Also need to return, oops, the result at the end. So display X, display X. We'll display Y. Okay, let's try that out. $147. Oh, whoops. I forgot to add the 2 right there. And I also need, there was something else I was just thinking about. Now it's already slipped my mind. Oh, I want to make that timer faster because I don't want to sit here and wait for that. So interval, turn that back to 1. I think it's only picking positions that are close to the player now. Okay, well, that sort of works. All right, let me also change is close. So I need to invert that logic, I think. I'm also going to expand this range. So let's go is close to player, and we'll say not. We don't want it to be the close to the player. So I haven't yet seen it get close to the player. And the player should walk around. Oh. Wow, is it that slow? Can't even walk. Oh, is it because I'm writing to the terminal too much? Okay, is close to player, not close to player. All right, let's stop writing all that stuff out because I don't know if that's the problem. Because something is slowing the game down to the point that I can't even walk around comfortably. It does not feel right. Could also be that I'm repainting the screen too frequently. I might have to clamp that down. All right. Let's stop writing this stuff. I don't know if that's a problem. I think there must be something else going on. Yeah, because I can't even move. Strange. I wonder what it is. Does it really eat the CPU that bad? Doesn't seem like it. So, let's check, is it main? I don't know if run engine loop is locking the FPS. Actually, I need to draw the FPS. So I have FPS counter. Let's take a look at the main of the silent siphon. And I'll be able to tell what the FPS is from there. So I go to modules main, FPS. Okay, render the FPS. I do want that. Just steal my code here. I'll put it into the other main of this. We'll just draw the renderer. We'll also draw the FPS on top. Window width, window. Okay, so we already have window width, window height. I don't need to actually call this every time. Oh, actually I do, I guess, if the person resizes the window, but let's just assume that doesn't happen. So render text, we need the small font. From that game, what did I use for small font? Okay, so let's go into assets and actually no, we'll go back into main. Do I have assets here? No. So erratic assets. And then, oh, small font, it's right there. But it's not what I want to do. I actually want to load the asset. So was it load asset or load font? Go back to assets. Load font, name, path, size. Okay. That's not necessary. Okay, so load fonts. We have the small font here, and I can now use that to render the text. So let's actually see if this works. Okay, it seems to be going a little bit more than 60 FPS, but that shouldn't be enough to keep the keyboard from working. It's not capped though. Clearly it's not capped. Then why is it so slow? Something is wrong about that. I need to check and see if the events are getting through. Actually, where is it? Handle input events. If input key down. Okay, this is where it's happening. So let's just write out when an event is found. So display event. just to see if the events are even getting through fast enough. Yeah, they seem to be writing out. So something else is preventing the movement code from running effectively. Zine says, how intense is the game? Should we look at it in top? I think it's fine. Like, I see my CPU reading up here in the panel, and it's not really going to 100% on any of the cores. I mean, it's probably close to that, but I think I'm just not handling the event correctly. Display key down, and do I have the time, the current time? No, I don't have the current time. Handle input events. Threading issue. No threading in this game. But thank you. Key down, and maybe I can just say like which one it is. Then I can tell if it's different each time. Input event key code. That's weird. So it does actually get the events. It seems to be responding to events at the right rate. Maybe there's something else. If binding handle game event. So let's go into game, handle game event. Display game. Oh, can I paste? Yeah, let's just use that. Because this is kind of stupid to have to keep doing this. Event. Just want to see if it responds as fast. Yeah, the player is not moving fast enough. And I wonder if I'm doing something to cause it to be rate limited. So, does it only happen when the timer pops? No. I'm tapping it constantly. Put that back in. Yeah, see? I'm pressing down, player move down. You see the events, and it's not doing anything. All right, I wonder... Let's see. FPS capped. Yeah, it's not capped. It needs to be capped. But that's not really the problem at the moment, I think. I think there's something else happening. World is passable. So, begin. Let's see what this does. So, that's interesting. Do we even get here? Display checking passable. Something's broken. World is passable is somehow not returning the correct value. So let's check world is passable. World tiles world. Okay. Oh, man. That's why. This is wrong. This needs to be not equal. So now that I introduced these new values, the player is standing on top of a 2. and it's surrounded by 2s. So now that code basically says, oh, if it's not 0, then it's a wall. So now we just need to check specifically for walls. So I think now it'll be fixed. Oh, not, oh, okay, not does not have a question mark. Yeah, we're good now. Great. Thank God. Nope. Not really. I mean, I guess let's not make such a hasty decision on that. Back to game. We don't need that anymore. Display. Don't need that because I think we're good on that. I think we're very good on that. And then we can get rid of, no, not that. Picked up item, we need that, unfortunately. No, not that. This. Okay. So, we did 2 things that I wanted to do. So I think we can finally call that one work item done. So we make sure we don't pick the player position for items and then show a timer gauge. So we're good with that. Boom. Yeah, my webcam definitely is slowing down every time that I run the game. I really need... Actually, I'm going to fix the streaming setup so that the camera and everything is not affected at all by what's happening on the computer. It's just I need another computer for that. Another for the collection. We're not going to do this right now. Implement traps. Traps could be fun. So let's say we have maybe about 45 minutes remaining in this stream, and we'll do another stream this afternoon. So I'm trying to think like what would be the coolest thing to do in the final 45 minutes. Maybe I can add traps and lock doors. We also need a win and lose state. Configurable player start and item locations. Oh, player start locations. Yeah, that could be cool too. Well, that I did. So the item locations thing is configurable, but we haven't done configurable player start. But honestly, I should do that. So maybe I can do that too. So the start position should also be configurable on the world map. Where would I be interested to see the player start off their game? Obviously, the place where we did start is kind of nice for that. You know, we could start right here. Say maybe 5. Man, it'd be nice if I could just, you know, arbitrarily move around these chunks. And also, let's go back into our org. I want to fix this to add 5 for the player start position. And what would we say? Like a pink of some sort? Scribe face, font lock. For the player start position, it could be, or the purplish, I don't even know. I'm using keyword face twice. No. Function name face, type face, warning face, constant face, font lock preprocessor face. Okay. I do that and then go back into world 1 and then do text mode. Now that 5 is purple. So that can be a start position. They can start right about here. Or here. Let's not put too many. I think a couple could be interesting. They could also start in the corner right here. So before we do anything, when we set up the game, we should do these position selection for player. I have the ability to do the calculation on that. I have access to the world data. Oh, this needs to also change. So create initial entities and pick positions. So we've created the world. We already have all the item positions. What I could do is start them all off at 0. And then run randomize the first time. So randomize. Yeah, I think that's the way to go. I need to have... So the randomize, basically all the logic that's in this part needs to be a function. So then I'll move this one up here, if you let me. Okay. Okay, and then I'll be able to do other things, randomizing doors and traps and all that stuff. What's it called? All entities. Okay, so randomize all entities. Hello, Aaron TV. So randomize item positions. So what this will do is allow us to say at the very beginning of, maybe leave it like that. At the very beginning of setting up the world, we can just say, all right, this is going to be position 0, 0. Can't speak. Randomize all entities. But we need to move this stuff. So init game might be the place for that. Shouldn't just be hanging around in the global scope of the module, that's for sure. So we can define the player as nil, define items as empty list, define traps. I think this should just be a record type, but I'll get to that eventually. Define doors. Okay, so that would be all of the things we need to worry about randomizing. And then we would just set these. And then inside of init game, that happens. Actually, maybe this comes first. Oh, no, 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 no. Okay, now we got that. So init game gets called where? It gets called in main. Yep, okay. And then what else? Anything else get called in the top level that needs to be fixed? Doesn't look like it. So now, at least setup should work. And the item should be somewhere else. Okay, cool. So it starts off in a different location. Great. I can still move. That's good. So then the next thing to do would be... Hold on a second. I'm just checking one thing. Move player. Okay. So we need to find the player start positions. So positions... I was gathering them in world.msc by using gather positions, I think. So what if we do the same thing for player? We take... We also probably should load the world data and set up the world inside that init function too. But we'll deal with that in a minute. So gather positions, let I need better key bindings for that. Gather positions, tiles. No, it needs to be world data. And for the tile kind, we're looking for number 5. So that's the player positions. So that will give us the initial player positions. And then what we can do is take a random position for the player. So that could be in here, actually. All right, here we go. Let's just do it right here. Set the initial player position, because we don't need to store that for anything else. So, man, gotta do another inner let. Start position is position to world, rand int, position list, no, position count, initial player positions. This is way too deep. So that rand int will give us an integer inside of the world. We have world width. Is that in here? Yeah, world width. So that will give us the position, but that doesn't actually give us the position because we need to take an item from the list. So list take, you give it the list first. And we need position list of initial player positions. You know what? I'm going to take that initial off because it's just way too long. Let's do that. So initial player. Okay. And I didn't spell that right, so didn't catch it. Position list, player positions, rand int. And this is not good enough. We even have to say car at the front of this for it to work correctly. So that should give us the initial position for the player. We pulled all the player positions, picked a random one, converted it to a world position. Now we have start position. So now we can just use that car start position, cutter start position. Let's try it out and see if it works. Position list. Oh, it's positions list. I forgot about the... Yeah, I don't like the name of that. Right here, which I think is accurate. So let's run it again, see if we get a different position. Now I'm here. Okay, so I think it is working. So every time you start the map, you are in a different position from a list of predefined positions, which is fine. Okay. That was a work item, wasn't it? Add configurable player start. That works. Okay, so the entities are going to be the things that wander around, and if you run into one, you're in trouble. Which actually would be pretty nice to have. Patrols. Let's see. You know, I'm going to take a 2-minute break, and I'll come right back, and we'll finish out a couple things here. All right, I'll be right back. All right, we're back. Let's see about getting some entities in here. Or some patrols, I guess you could say. So the thing about the patrols is they will only move under two circumstances. One is the timer cycles, and the other is when the player makes one move. All the other movable entities will move in some direction, and that's sort of like how NetHack is, where nothing happens until you make a move, and then the whole world sort of takes one tick of action. What is our interval? I got it way too low right now. Let's put it back to 10. Make it the real thing. Run it again. Just make sure everything's copacetic. Seems good. Can I run over there and grab the item? Boom. Okay. 10 seconds is too long, at least for this game. But I need to make it, maybe the item needs to show up way farther away from where the player is for this to be good. So I just don't want to end up in a position where there cannot be an item position away from the player. So, but if I have the map fleshed out enough to where there's rooms all around, then it should be fine. So we're gonna do the patrols now. Let's just get it done, and then we can do the other fancy things like doors and traps later. So we have patrol.msc, define module, erratic patrol, define record type, patrol. This is considered an entity for the sake of what we need to do. The fields would be X and Y. Honestly, whoops, sorry for that. I don't know. Let me close some tabs here just to make sure that we're not eating up too much CPU. I think Firefox is killing a lot of stuff here. Maybe that will help with the webcam. So maybe there's only one kind of patrol, one kind of behavior. We can add some more variation to that in the future. So let's see. We're going to define some functions for this. Obviously, we need a render patrol, but we can just steal that from player. Render player, we basically just want the same behavior. So I'll just do this, and I can just find and replace player to patrol. Boom. Patrol color. So maybe we can get like a chartreuse green kind of thing going on so that it sticks out a little bit. What was I gonna do? Oh yeah, I gotta go to player and snatch that color reference. I'm gonna put it right up here. Patrol color is gonna be, let's see, what is this color that I'm on right now? Describe face. This is B6E. I like that color. Let's go into GIMP and get the RGB. Zane says, is there plans to see mesh in this game on something like Channel X? Well, once mesh is usable by the average hacker, which it isn't right now because it's way too buggy and incomplete, I would definitely like to put it on either my own channel or on even the main Geeks repository. At least to have mesh there. It could be pretty interesting to have it in there because it's under an open source license. There's no reason why it can't be there. So I would like to eventually have that be the case. But if nothing else, I would put it in my own channel if that if it would be usable for other people. 719024. 9024. Okay. So patrol color. So we can render a patrol now. We need to be able to create a patrol, but really it's not super complicated. Same thing for player, I suppose. Player has inventory. We haven't implemented inventory yet. We need to do that. This guy does not have anything. I'm wrapping another make function, which is stupid, but this won't be necessary in the very near future. So back in game, we want to set up patrols. Now the question is, do we want to have another way to set possible patrol positions, or do we want them to just be able to show up anywhere? I think just showing up anywhere is perfectly acceptable. So maybe it doesn't need to be anything fancy. So in game, we have items. We'll also add patrols. And then initialization, we're going to want to randomize, but that can be taken care of by the actual randomize all entities function. So what we need to do first is create some number of patrols. And should that be random per level? I would guess so. So then minimum number of patrols would be maybe 2, maximum maybe 5, I would say, and then pick a random number in between that. So create the patrols. Let loop count rand plus 2 rand int 3. So the maximum would be, well, 4. Maximum would be 5. The minimum would be 2. And we're just going to do a simple little loop here where we set the patrols list to const a new patrol 0, 0. We don't really even need to set the position initially. And that's it. And then we loop until we have count. Let's say max patrols count 0. If less than count max patrols, we do this again, and we loop with max patrols and plus count 1. And then that should be done because we've already set the patrols list. We're building them up. Probably there is a higher level function that would make this a little bit easier, but it doesn't matter. We already got this written. So that will create some number of patrols, and then randomize all entities should then randomize patrol position. So randomize patrol position. So loop, well, no. Randomize positions already does this. So if I just copy that. Patrols, world item positions, let's say world floor positions for patrols, because we want any walkable position that could show up. And then this is going to be patrol. We'll say patrol X set, patrol Y set, and then patrol on these two as well. And then we don't, well, let's still use the same close to player logic on that. Then we randomize item positions. And when we render the game, we also need to render the patrols. No, that's just inefficient. Let's do this. Item, patrol, yes, yes, yes. Okay. So that should render them. And we don't need to do any updating right now because they're not going to move until the player moves. So let's just see if they render to start with. Create patrol has not been exported. Oh, it hasn't been imported. That's the problem. So let's go here to where player is. We'll just drop in patrol also. All right. RGB line 11 script. I think patrol needs to pull in import substratic renderer. And 58. It's not in this file. Count. Operands must be numbers. What is count then? I must have done something really dumb here. What did I do? Thing is, it's not telling me which file it's in. It'd be in other files, not this one. What about positions? 58? Nope. It has to be here. What could it possibly be then? Display count. Whoa. You know what? Cons is not complaining when it doesn't have a second value, and when you execute it, it's eating one off the stack. That's dangerous. Okay, I need to do something about that right now because I think that might be the cause of some other very strange issues I've been seeing. If I forget that parameter, it's a bad thing. So let's go to was it maybe in list.c cons? Where is cons? Oh, the compiler does cons. Why isn't it not complaining? Compiler? Cons? OP cons? Token kind cons? Maybe it doesn't even know. It's treating it as a call. Damn. It needs to be special cased. Okay. So I'm going to leave a little note for myself here that cons needs to be handled specially so that we can ensure there are two parameters. Because that is very confusing. And I'm honestly a little bit surprised that I saw that. Because this is supposed to be patrols right here. The only reason why I realized it is because display count is here. Then I write display count and it writes the same string again. So it means that somehow it's reusing the same value on the value stack. Okay, this is something else now. Add index. Interesting. I'm glad I added that. List take. So this is for randomized positions. Positions list. Valid positions. Randomized positions. For patrol, we're giving it floor positions. We've seen it work for the player already, so that list take for the player is fine. Maybe what I should do here is write out a little bit more about why it's happening. So display the LST, display the item index. $112. Why is there a sublist in there? Oh, wait. I think something is wrong with this algorithm. There's two sublists. That makes no sense. This came from what? All right, let me make sure. Randomize positions. So let's do this. Display randomize patrols. Just want to make sure that it's actually hitting that line of the code before. Why did printing something actually help that? That doesn't make any sense. And then it crashes. Oh, because... What is happening? So... It's got a list in a list. I think all the position numbers are correct. But somehow it keeps nesting itself. And that's coming from the initial positions list. So let me check the positions algorithm. Because it must be coming out like that. Unless... The other possibility is that something I'm doing on the take list operation, or list take operation, is mutating a list incorrectly. And it's affecting the original list of positions. That is very possible. So what if I take a look at game list take? On list take, I really need to see what the result is. So this is the place where the result happens. Begin. I don't want to run it twice. Maybe it needs to be a let. Let. Oh. Okay, so we got X here. That's wrong anyway. That doesn't make any sense. Object is not pair 0. Yeah, no kidding. Something's wrong. Const car remaining. All right, let's write out the individual parts of this. So display car remaining. Footer remaining. And also result. So the car is 105. The result not really result. It's more like new list. Result to new list. So append to the new list the list of car remaining. So we have car remaining, which is 105. We have the new list, which is empty. I don't know if it's, oh, maybe it was, I think I should write out the original list too, so we just have it very obvious what's happening. Called what? LST? Run it again. All right, original list is 105. $105, 197, 319. The result is 319. We remove 319 from the list. Oh, that's right. I think I'm not, Consts are remaining. I'm consting the new list with a cdr of remaining. Something is creating like a nested list here, and it's not lining up correctly. I got a few more minutes here. I think that once we get this figured out, at least we can have the entities on the screen, because it did show up. But just I think the list is a little bit broken now. So we picked 319. We've taken it out of the list. So this part right here. So this first line printed as list, car remaining is the result. New list is the items that have been added to the new list, and that's looking right. Then the cdr of remaining is empty list, which is right. Then X is the result, which is 319 with a nested list behind it. So it really depends on how we deal with this nested list. The car of this location must be the nested list. And why is that the case? Because I would actually want this to be a flat list so that it's easier to deal with. So the new list is already a list. I thought what I was doing here is consting a list. Oh, no, I'm not actually doing that. That should be an append. Maybe that's the problem. That looks right. I don't know why we're getting a complaint about object is not a pair, but this is correct. So that result looks better. Now, I think all this error stuff started happening after... Oh, I didn't return it. That's why. Maybe this will fix it now. Yes, it's fixed. Okay. So we can see now that there are 4 patrols. The player and the items. And then everything gets randomized whenever the timer cycles. So whenever this timer hits, all the entities and the item are going to be moved to new positions. Cool, huh? Great. And also, they're not being moved that close to the player, so at least the player has some breathing room. Though, I think I would like to shorten that distance for the enemy thing. Maybe within 1 or 2 squares. So let's delete all this mess here. No, not that one. Well, yes, actually some of this one. This part's what I want to delete. Let's just delete all the prints and delete the X, and then get rid of the let. And just make this be a plain expression. Make sure that it works before I move on. Okay, seems to be doing all right. Now, the last thing is to is close. I want to be able to set that distance. So we're going to say distance here. And for item is close. For item positions, it would be 3. And for patrol positions, it would be 1. Let's try it again. Let's move around a little bit. Okay, so that's pretty close. That's good. And now you're trapped, and you can't get to the item because you can't move through the enemies very easily. All right, so we got far enough. I think this is pretty good. Few new things added since the beginning of the stream. So we got patrols in, we got item and patrol position randomization. We expanded the map a little bit. We need to do some more work. I mean, we may only have one map by the end of this, which is fine because it'd be nice just to have a map that is completed. Probably some other stuff I can't remember. Oh, we got the little timer down here now that you can see. So pretty cool. I don't know. I think it's a pretty good result for the amount of time that we spent this morning. So we're going to do one more stream today, and that's going to be it for the Ludum Dare 51. On that stream, we are going to try to implement actual win and lose states so that, you know, if you catch the item, then you win. But if you run into a patrol or maybe into a trap or something, then you lose. We may need some other stuff like items you can pick up for unlocking doors or dodging traps or maybe dodging patrols, etc. So we can try to add those as time goes on. But I think the most important parts of the game logic are now implemented so that we can do position randomization on the timer, and then, you know, moving around, picking things up, all the things that we need to do for having some kind of game. So that's good for now. So I will try to come back around 4 to 5 hours from now. I'm going to schedule the stream in advance. So you'll see it on the Flux Harmonic page maybe about 30 minutes to an hour before I go live. And then we will do another maybe 3 to 4 hour stream, and then it will be done. By the end of that stream, I'm going to try to get things to a state where someone could download a build of this and play it, but the likelihood is that it won't be the case. I think mainly the point of doing this is just to do it, not so much to have a playable game at the end. I don't really care too much about the playable part. It's more fun to actually see it come to life. So anyway, thank you all so much for being here this morning. I really appreciate the interaction and your attention, and hopefully I'll see you this afternoon. So until then, keep it creative. Thanks a lot.